Hello learners, welcome to the channel Video Lectures for Engineering Students. Today in this video, I'll be explaining a problem involving the work done equal to change in kinetic energy. Okay, so the principle we will be going to use is work done is equal to change in kinetic energy. So the statement of the problem is a bullet of mass 81 gram and moving with a velocity of 300 meter per second is fired into a block of wood and it penetrates to a depth of 10 centimeters. If the bullet moving with the same velocity was fired into a similar piece of wood of 5 centimeter thickness, what will be the piercing velocity? And find the uniform resistance also. So that is a statement of the question. So in this question, a gun bullet of a weight 81 mass 81 gram, which is having a velocity of 300 meter per second, is fired onto a wooden block to penetrate to a depth of 10 centimeters. Okay, so here we will be using the condition, that is work done, or the principle work done is equal to change in kinetic energy. Okay, so the given data is mass of the bullet m is equal to 81 gram and velocity v is equal to 300 meter per second. Okay, so there are two cases. In the first case, you can see I have drawn a figure here. That is, this is the block of wood. Its thickness is more than 10 centimeters. Okay, and a bullet is being fired with a velocity of 300 meter per second onto the block. Okay, so as far as this bullet is concerned, when it is touching this surface, okay, when it is touching this surface at this point, say at this point, its velocity is 300 meter per second. That is, u is equal to 300 meter per second. Okay, and it will be going inside the wooden block, and while passing through a distance of 10 centimeters from this face, that is, this distance is 10 centimeters, and reaching this point, what happened? The velocity reduced to 0. That means it could travel only 10 centimeters through the wooden block. That means at this point the velocity is 0 meter per second. Okay, so the velocity at this point, that is the initial velocity u is equal to 300 meter per second, and the velocity at this point, that is after traveling 10 centimeters through the wooden block, the velocity became 0, or the bullet came to a stop or rest. Okay, so that is a figure. Then in this case, to stop the bullet, the only force acting on the bullet is the resistance, and it is told in the question that it can be assumed as uniform. The resistance is uniform, and this uniform resistance is the only force involved in stopping the bullet when it is traveling through a distance of 10 centimeters. Okay, so work done, the equation is work done is equal to change in kinetic energy. So if R is assumed to be the resistance, the uniform resistance offered by the wooden block or the material of the wooden block, then R into S, where S is the distance travel, is equal to half mv square minus half m u square, where this is the final kinetic energy and this is the initial kinetic energy. So when we rearrange this, we can write it as R is equal to m by 2s into v square minus u square by cross multiplication. So m by 2s into v square minus u square is the equation for resistance offered by the wooden block. Then m is equal to 81 gram for the bullet, and when it is converted into kilogram, it will be 0.081 kilogram, and u is equal to 300 meter per second. Then v is equal to 0 meter per second, and s equal to 10 centimeter. Convert it into meters, 0.1 meter. So by substituting the values for r, we will get r is equal to minus 36450 Newton or minus 36.45 kilonewton. Why that minus sign? The minus sign is because in which direction the resistance is being is acting? Opposite to that of motion. Normally, when we do problems in kinetics, the forces or the quantities which are in the direction of motion, the same direction of motion, is taken as positive. Others are negative. So the resistance will definitely be in the opposite direction of motion of the bullet through the bullet block. Therefore, in the equation we have put it as positive. So when we solved it, finally we got it as negative. That means the resistance is in the opposite direction, and our assumption of the direction is in the was just opposite to that of the actual one. That is why this minus sign. Okay. Then in the second case, what is given in the problem? In the second case, it is given that the same a bullet with the same velocity is fired onto another block made of the same material of the previous block, but the thickness is just 5 centimeters. Okay, so when it was fired into a bigger block, a thicker block, the bullet could penetrate through only 10 centimeters. Okay, so when it moved through 10 centimeters, the velocity became 0 and it came to a stop, rest. But if it is only 5 centimeters thick, means if the velocity is same, hitting velocity is same, definitely the bullet should come out of the block, isn't it? So we need to find with what velocity it will come out of the block. Okay, so here I have drawn another figure in which the bullet is striking on this surface at this point with the velocity equal to 300 meter per second. That is, at this point u is equal to 300 as in the previous case, and it is traveling through 5 centimeters. That is the total thickness of the block, and it will reach here, and obviously it will come out with some velocity. That velocity is v, that we need to find out. Okay, so with what velocity it will come out of the block, that is what we need to find out. Okay, then we will use the same equation, that is r into s equal to half into m into v square minus u square, as in the previous case. Here also, the only force acting on the bullet to stop it or to reduce the velocity, we know that the velocity will be reduced when it is coming out of this block. So the only force which is acting on this bullet to reduce the velocity from 300 to something lesser than 300 at this point, it is the resistance offered by the material. And the material is same in both the cases. The resistance will be same as the previous case. So here in this case, for this R, we can use the same value we got here. That is 36.45 kilonewton. 36.45 kilonewton. Okay. So the data given are S equal to 5 centimeter. It is 0.05 meters. M mass is equal to 0.081 kilogram because it is the same kind of bullet. And the U is equal to 300 meter per second, the initial velocity with which it is hitting the block, and we need to find out. So RS, that is, this is the force into displacement, that is work done. Work done is equal to half into m into v square minus u square. That is, work done is equal to change in kinetic energy. Substitute the values. R is equal to minus 36450 because it is in the opposite direction of motion of the bullet. Therefore, minus 36450 into 0.05, that is a distance travel. That is this much distance. This is 5. That is equal to half into 0.081 into v square minus 300 square. Okay. So when we solve this, you will get v is equal to 212.13 meter per second. So these are the answers to our questions. That is, first we found out the resistance. That also we were asked to find the uniform resistance offered by the material. And we have in the second case, considering the second case, we have found out the velocity with which it will be coming out of the block. So it hit the bullet hit the block at this surface with a velocity of 300 meter per second, and it pierced or it came out of the block with a velocity of 212.13 meter per second. It is less than 300. So the answer is at par with the expectations. Okay.